Swayam Prabha. Digital India. Educated India.
Good morning, good afternoon, and hello, my friends. This is the 20th lecture of each of being of half hour duration, and we are just at the middle of the course for the project management. So today we will consider the concept of PERT CPM. This is just starting, and if you remember, we considered what are the concept of activity on arc and activity on known concept, and based on that we will now proceed. So if you see the slides, which is the 227th one, so prior to constructing an activity network, there are some simple rules of thumb you need to become familiar with as you develop the overall set of activities which makes the project. So these rules are very helpful in understanding the logic of the sequence of the activities based on which we will work to basically find out what is the critical path or what is the time duration taken for a project, and based on that we will take a decision whether crashing can be done, whether that set of activities are optimal or whether they are critical, whether resources should be utilized in order to finish the overall work before time, and if resources are being utilized, what is the overall consequence on the general cost structure for the project. So some important points regarding activity network. Some determination of activity precedence ordering must be done prior to creating the network. So you need to understand which job comes first, which job comes second, whether there is a sequence of jobs which has to be followed, or whether they can run concurrently, or whether there should be a delay between two activities and jobs. So this should be well known to the project management team who are basically trying to implement the project. That is to say, all activities must be logically linked to each other. Those that proceed and other subsequent activities should be planned accordingly. The network diagram usually flows from the left to the right. So if you remember the decision tree diagram which was there on the left, we had the start where you are trying to basically start off your total decision process, and on the right was the end. But even though the whole process basically was from left to right, actually a decision whether there was a logic depending on the expected value of the decision, whether you should continue with that particular set of activities, not continue with this set of activities, was basically taken from the right. So this would not be technically the case in many of the actual so called rules based on which we are trying to analyze the PERT and the CPM. An activity cannot begin until all preceding connected activities have been completed, which is very important to know. Arrows on the network indicate precedence and logical flows. Arrows can cross each other, although it is helpful for clarity's sake to limit this effect when possible, because crisscrossing would basically make it much more confusing. The fifth point of discussion is that for the important points regarding how the activity network is made and what should be remembered is each activity should have a unique identification associated with its numbers or letter code. Like if the letter code is A, B, C, D, they should not be in clash, or if the activities are starting at 1 and 2, so others should definitely not be such that there is a clash, like 1 and 2 should be unique. So other can start at 2, but they should not be all starting at the same point or ending at the same point, considering the numbering. For simplicity, these identifiers should occur in ascending order. Each one should be larger than the identifiers of the preceding activities. So as we write down the numbers in column format, the numbering should be basically the least should be on the top and they should go down as we go in the logical sense below. Looping or recycling through activities is not permitted. Even though looping and cycling is not permitted, if you see this sixth point, remember that looping would be a part of the consideration when we go into GERT and QGERT concept. So that was one of the main book based on which we will try to cover these concepts were basically by Pritzker. Although not required, it is common to start a project from a single beginning node, even in the case when multiple start points are possible. A single node point also is typically used in the project end indicator to signify the project has ended. So, consider a very simple example of precedence diagram in the network concept. So, it can be like A, B, F, H, then J, or else the sequence of the activities can be in the second bullet point A, C, E, H, J, third being A, C, E, G, J, and fourth being A, D, I, J. Similarly, for others starting with B, C, E, F, G can be mentioned. So, if you look at the first, second, third, fourth bullet point, it means that A is the first one. Now, if I ask the question that what set of other jobs or activities are there after A, so what you will do is that basically lay your attention on the set of activities which are after A. So, if you see the first bullet point, the second, third, and the fourth, you will see that after A you can have B, C, and D. That means when they start would actually mean that what is the relationship between A and B, what is the relationship between A and C, and what is the relationship between A and D. But it would also mean that B, C, and D may start at the same time, may start at different time. So, let me say that in simple words. It may also mean that B can only start after A ends, but it may not be the case of C. C can be such that C starts only after A starts. So, the starting point of B and C are different, and D can be, say for example, it only starts after, say for example, half of A is complete. So, how they are denoted in the diagram concept, I will come to that later on. So, similarly, after B, C, and D you have F, E, and I, and correspondingly the sequences are given. So, if you see this is what I meant. Then after A you have B, C, D jobs and activities, and after B you had F, after C you had E, after D you had I. So, the sequence of activities which was shown in the set of slide which was 230, if it is converted into the activity the precedence diagram concept, it has basically A being followed by B, C, D in some sequences. Then after B you had F, and after C you had E, and then as you proceed more on to the right, F and E would basically lead to H, E would lead to G, and D would lead to I. So, once H, G, and I are done, complete in some sense, it will basically go to the end job which is J, which completes the work. We also know the estimated duration for each of the activities in the project network and apply them and to determine the exact time necessary. So, say for example, if the duration of the jobs are given as given in this 4 bullet points, star bullet points, path A, B, F, H, J has the durations accordingly as given. 4 is basically the time duration which is taken for completing the job. So, if you have A, B, F, H, J which is 5 in number, so obviously there are 5 such durations. So, A takes 4. So, if you consider the concept of A would basically be 4 both in path 1, path 2, path 3, path 4. If I consider B has a duration of 4. If I consider C has a duration of 2 both in path 2 and path 3. Similarly, if you note all the job timings or the durations, if you add up, they give you the total duration which is being taken for path 1. The first one is 18 days. Similarly, for the second, third, and fourth, the durations are 14, 14, and 16 days. So, if you consider the diagram here, actually now it is basically giving you the values, figures inside the square such that they will give you an estimation or the concept that when is the earlier, concept based on which the job can start, what is the earlier concept based on which the job can stop or finish, and all this information is there. So, if I consider, say for example, the job A, the 0 means basically it has to start on the 0th day. That means when my project starts, the duration is given as 4. Now, if I consider, say for example, job B, it means that it can start at the end of day 4, which means once job A is finished, 4 days has been completed, then only B can start. So, if I consider the duration of job B, it is basically 4. So, the total amount of duration needed to complete A and B combined together is 4 plus 4. So, similarly, everything is given accordingly here. So, all the values how they are calculated, I am going to come to that very soon. So, once you have completed the backward pass, that means either going in the concept where you go from the left to the right or you come from the right to the left, we can determine. So, these what is backward pass and what is the concept of forward pass, I will come to that. So, we can using that we can determine individual activities, their floats for each task as well as for each path through the network, what is the overall time duration taken and whether that time duration is critical or not. Again, float informs us of the amount of time and activity can be delayed and still not delay the overall project. To illustrate the implication of float, suppose that activity C is delayed and cannot start until 3 days after the original schedule. So, those concept how they are done, what the third bullet point basically means, if you refer back to the last slide, which is the 233rd slide, you will understand how it makes sense. So, I am just mentioning that in the qualitative aspect, we will slowly start solving the problem in detail so that you will understand that how the concept of forward pass, the backward pass are utilized in order to find out the total duration, the slacks, the critical activities, the critical path and so on and so forth. We will also try to understand what are the implications of the delays and whether the delays have as a consequence on the total duration of the project. So, if we consider these implications, the total duration or delays of the project in many of the cases can be 0, in the sense there would be some slacks for which the delay is admissible such that any shifting on an activity or a job can be done. With 4 days of float for activity C, a delay of 3 days will not affect the overall length of the project. If you go back to the last slide, which is again I am mentioning 233rd slide, you will understand that is true. One important point to remember of activity float is that it is determined as a result of performing the forward and the backward passes, the concept which will come very soon and what I have been mentioning, that how you calculate the total float and how you find the slacks accordingly. Until we have done the calculations for this ES, EF, what are these, I will now explain. So, until and we have done the calculation for the early start ES, EF is early finish, LS is late start and LF is late finish. We cannot be certain which activities have floats associated with them and which do not have any slacks associated with them. Using this information to determine the project critical path suggests that the critical path is the network path with no activity floats, such that it is critical to understand that any delay in those particular activities would definitely have a negative impact on finishing the time duration of that project. In our project example, which we just considered, we can determine the critical path by linking the nodes with no floats. That means, if the floats is 0, obviously it means that there is no leeway of changing the duration or the end of those particular activities or jobs. So, here with no floats is the set of sequence A, B, F, H, J. We can also determine that float for individual path floats which are there. So, there can be other paths also to reach that total project, but which means that if one of them is critical, the others would basically have some floats. So, that means there is some leeway in trying to change some activities in that path where there is a float. Which is to say, let me continue, the linkage of each node within a non-critical path would be there. For example, if you consider in that diagram which we just discussed, the path A, D, I, J has 4 days of float. That means 4 days can be utilized for trying to readjust in case of emergency or some changes in the activity start and finish has taken place for this, for the sets of activities which are there on the non-critical path. So, consider this diagram. This is based on the fact that A has 14 days, B has 3 days, C has 7 days, D has 4 days, E has 10 days. So, generally it means that after A ends, you basically can start B and C and the corresponding number of days is given. After C is done, then some D work, whatever the activities has to be finished, that it ends and in a certain time, and provided D and B is finished, then only you can start E. So, you start at 1, finish at 5, considering the activities are A, B, C, D, E in some sequence. Now, in this diagram, in order to make you understand, I have marked the path or the set of paths of the activities which are critical. So, this is basically A, C, D and E. So, now the question is why it is critical, why not B is not critical. So, I am just explaining it qualitatively. Now, if you see, after A ends, 14 days are already over for the project. So, if B and C start immediately, then B would end after the end of 17 days. But in that case, C has to complete extra of 4 days because C has 7 days. So, if it has to basically complete the whole work for C, so extra such 4 number of days is required to basically finish C. Technically, it means that B could have been delayed by 4 days, such that if 4 days have been the delay for B, then C would have completed 4 days of its work. So, say for example, on the 18th day, C would start at some portions of the C has already been finished. So, from 18th, 19th and 20th day, the work would basically continue for C, and then considering that 18 days are already over, B would also start. So, the end of B and end of C would be such that they would end on the 21st day. But consider now again if D has come into the picture, which means that if I now till now I have not considered D. Now, if D is also considered in the picture, so the total number of days before C and D can be finished, considering B is also there, it would mean that now I am considering 2 sets of jobs at one go, which is C and D and is B. So, 14 days is over here, C and D has 11 days, 7 plus 4. So, now if I start B, B would basically finish on 3 days. So, if I consider 7 plus 4 is 11, 11 minus 3 is basically 8 days of total leeway is there where I can adjust B such that there would not be any delay when C and D finishes and B also reaches at that same point of time it finishes, because until unless B, C, D finishes, you cannot start E. So, the whole critical path is the red one as shown in this diagram. So, main drawbacks for the critical path method and the project evaluation review technique is that they do not consider any feedback loops, which I mentioned that in the beginning of the course, and will consider this concept being taken into the fact for JERT and QJERT concepts. So, hence feedback loops or re-evaluation loops, which is very essential for any projects, are not there under CPM and PERT. They only consider end to start. So, this concept I will just come within few slides. So, this PERT and CPM only consider end to start concept, not the other one which I had just mentioned, like end to finish, then or finish to start and finish to finish concepts are not considered. So, out of these 4 concepts which we will just explain with a diagram, This PERT CPM only considers the end to start relationship between any two consecutive activities or tasks or events. So as looping is not allowed, so this is what I mean. So the that one means basically if you had this one as, so this one say for example was A, this was B, this was C, this was D. So any relationship between C and D where the looping is being done is not allowed in PERT CPM. So now if you remember, I mentioned about the concept of end to start, end to end, start to end, and start to start. So let me explain it with the diagram, which is very nicely explained in this 241st slide. So consider the activities are A and B. A and B are shown not to scale, in the sense the number of days being utilized for to finish A or number of days which is required to finish B are not shown in their sizes. They are just shown as activities. Now if you consider the relationship between A and B, there are 4 relationships which can exist between A and B. The first one, if you see the black bold arrow, it means that B can only start after A finishes. So they cannot be anything like B starting somewhere in between when A is progressing. That's not allowed. The second one, which is the pink one, so let me consider the second one, which is shown here. It is basically the end to end. End to end means the number of days stipulated between the end of A and end of B is fixed. So when they start, whether B starts before A or whether B starts after A doesn't matter. It only basically mean that end to end structure of the number of days is fixed and cannot be changed. That is the rule based on which we proceed. The third concept is start to start, which is shown in this greenish blue line, the arrow. It means that the starting of A and the starting of B are linked to each other with the number of days. It has no mention about the ending of A and the ending of B. Like in the first one, it was ending of A and ending of B were linked. Here it is the start of A and start of B which are linked together. And the last concept is basically start to end, which means that the starting of A and the ending of B are linked together. So it doesn't mention that when A would end or when B will start. That relationship is not mentioned. Only thing is start and end concept between A and B are required. So for the CPM, which is the critical path method and the PERT method, we will only consider the end to start concept, based on which we will find out the slack and the critical path and the floats. So to evaluate the time duration of an activity or job, we have to evaluate 3 different times, which are as given: T naught, T suffix O, T suffix M and T suffix P. So if you remember a few classes back, I have been mentioning about optimistic time, pessimistic time and the average time, time and again. So these are what I meant by T suffix O, T suffix M and T suffix P. So TO means is the optimistic time, optimist concept considering that all the resources are being optimally utilized. TM is the expected or the mean time and TP is the pessimistic time. So hence if I need to find out the actual time required to finish the job, considering the distribution is beta, the average is found out and given average, that means based on which we will do the calculations, not the TM part. It is given by T naught plus 4 into TM plus TP divided by 6. So the overall, if you see the probabilities or the weightages we are trying to give to the time is 1/6 for the optimist time, 1/6 for the pessimist time and 4/6 for the mean time. So this is the distribution based on which, as I mentioned, beta, and then we proceed to find using T, which is used for all our calculations. And similarly we can find out the variance also if required. Remember that we usually plan a project considering man-hour days. Hence it is important to evaluate the cost structure for each individual activity, job, task and then extrapolate it to find the total cost of the of the project. So, if I consider very simplistically, the total cost of that particular project would be based on the fact that what is the overall cost for each activities added together. So, if I want to find out that what is the cost for the first set of asset activity, it would be T1 would be the time taken for activity 1 multiplied by the cost, which is C1. Here I am considering C1 as linear cost. It can be quadratic also or some other polynomial, we are not going to consider that. The second would be the time taken to find out the overall cost for the second set of activities, which is T2 into C2. Similarly, for the last one, it would be Tn into Cn. Here TIs are the time period for an activity job task, and you must consider all of them, which is the conglomeration of activity 1 or 2 or 3, whatever it is. Here CIs are the corresponding cost per unit time. So, as I mentioned, the costs are linear in nature. So, as I mentioned in the diagram last, so the critical path is basically as shown, the red one, which is 1 to 2, 2 to 3, 3 to 4 and 4 to 5. So, now if the cost per unit for the paths 1, 2, 2, 3, 2, 4, 3, 4, 4, 5 are correspondingly given as 5, 10, 10, 15 and 25, then the total cost would be 14 multiplied by 5 for the first set. Then you have basically 3, which is the number 2 for 2 to 3 is 3 multiplied by 10, which is the second one. Then again for the next one, basically the total job, the total time taken, obviously that will come into the picture, would be 4 into the fact, which is basically now 15, and the last but one would be 10 into 25. But obviously, even though B is not in the critical path, cost would also come into the factor. So, that cost factor would be 3 into 10. So, if I want to find out the overall cost, don't concentrate only on the critical path. Critical path is basically the path which should be considered in order that any delay in any of the activities would affect the overall time duration negatively. But if I consider the cost factor, it will be 14 multiplied by the cost component per unit day for A. Similarly, 3 multiplied by the cost component for activity B. Similarly, for C, which is 3 multiplied by the cost component for activity C. D would be 4 multiplied by the cost component for D, and the last one would be E, which is 10 into the cost component for activity E. So, two different scenarios, considering there is a penalty of 20, some monetary unit, whatever it is required, for overshooting the stipulated time duration of the project, which is 31 days. So, due to some unavoidable circumstances, let us consider the time duration for activity B increases from 4 to 3 days, increase to 4 from the 3 days. Then the incremental cost would be, the number of days is 1, what is the cost per unit day is 10, we will consider it is not increasing, it is a linear constant function, if you remember I mentioned. And from this we can find out the percentage increase in the cost of the whole project. As there is no overshooting of the time duration, we only incur the additional cost, which is 10. Hence, percentage increase would be, if you consider the overall cost, which was 440. So, considering it has overshooted by 2.3%. Now, if I consider due to some unavoidable circumstances, the time duration for activity C has increased to 4 from 3 days, then the incremental cost would basically come from the fact that C is increasing, which is 1 by 10, plus the fact that E, which is the last job, is also increasing by 1 day. So, it will be 1 by 20. So, hence the overall cost is now not 10, but 30. Hence, critical path being affected would have a more devastating effect on the total cost component, which has now increased from 2.3 to 6.8. We will do the calculations later on and slowly proceed how we find out use the forward pass and the backward pass method to solve the critical path method. So, with this I will end the 20th lecture, and I hope the students understand the concept very clearly. For any questions and queries, please write to the forum. Have a nice day. Thank you.